Here is a practice test problem to write equation of a transform function whose graph is given to us. Now this is a graph of absolute function, and let's try to figure out what transformation it has gone through. So the best point to start with is always the vertex in absolute function. So we note that the vertex is at 0.43, so that is the vertex, which is at 4,3. Now the graph has been reflected on x-axis, moved to 4,3 position, so that part is okay. Now we need to figure out what is the kind of horizontal or vertical stretch on it. So as you can see, normally the absolute function, if I keep it at here the vertex, it would be normally kind of like this. It is like 1 over x, correct? So that is a normal. So what we notice here is that there is a horizontal compression by a factor of half, correct? So that is another transformation which we need to take care of. In general, the transform function can be written as a times f of k times x minus p plus q. Now, since the vertex is at 4 and 3, we know the value of p and q, and now it is reflected, so a is negative. Now we can treat this as a vertical stretch, or vertical stretch from this position, or even as horizontal compression by half. So either way we can get equation of this graph, right? So we can write one equation as like this: a as minus, and the function given to us is absolute function, so let's write absolute function, and k, we are treating this as horizontally compressed by a factor of half, right? So it was 2, it came to 1, so by a factor of half, that means k is 2 for us. X, it has moved p units, that is 4 units to the right, and 3 units up, plus 3. So that equation actually fits for this given graph. You can check some points to just confirm whether it is perfectly fine or not. For example, if you plug in this point, which is 7, then what do you get? Do you get minus 3? That could be a check, right? So if I plug in 7 here, then I get 7 minus 4 is 3. 3 times 2 is 6. Minus outside and plus 3. Yes, we do get minus 3. So this equation is perfectly fine. The alternate equation could have been that we consider this as a vertical stretch by a factor of 2, right? That could be an alternate equation. So we could have written also this equation as, let's say, g of x equals to minus 2 times absolute value of x minus 4 plus 3, right? This should be absolute, so it's a straight line. So it's an absolute function. So that is how we can get the equation from the graph. So the critical points here are, for this particular graph, notice the transformation. So we can go backwards and find these points, which is the vertex. And then we can treat the stretches and compression as horizontal or vertical, and accordingly write our equation. So that is how it is to be written. Thank you.